Today we're going to be taking a look at using equations to solve word problems. The last set of notes that you looked at talked about translating word problems into algebraic expressions. And so we're going to use that idea today to solve for a specific item. So the first thing that we're going to do is to define our variable that we're using in the problem. What are you trying to find? We want to use a let statement to define this variable. And we'll talk about what a let statement is in just a moment. Number two, we would set up the equation and solve, just like we did yesterday. You would go about trying to get your variable all by itself and trying to figure out what your variable is supposed to equal. And then we answer it. Okay, and so give exactly what the problem is asking for. So give me the answer based on what they were asking for in the first place. So let's take a look at some examples. I won't do every example, but I will do a few and give you the answers, and then you guys can kind of practice these on your own as you're working through them. So on number one, it says that Connor deposited $84 into his checking account. If his new balance is $451, what was his balance before the deposit? So when we're coming up with the let statement, we're asking or we're saying to let x, and then we tell it what it's supposed to equal. So for our let statement, we want to say let x equal the checking account balance. That's what they're asking for us to find. And that's the thing that we're not sure of. So we're going to use that. And we know that in order for him to have gotten his new balance that he had in this problem, he had something already in his bank account, and then he added another $24 to it. So if I'm not sure what he started with, I'm going to say x plus the amount that he deposited, this $84. And this is supposed to equal 451 by the time that he deposited this money. And so then now for us to solve, we would just solve this problem like we normally would. In order for me to move the number away from my variable, I have to subtract it. We have to do the opposite. So in this case now, I get that x is equal to 367. So his account balance before he deposited the $84 was $367. And that's it. So let's take a look at the next one. I'm going to look at number 3, and I'll give you some answers for 2 and 4. So on number 3, we have 3/4 of the 8th graders at Kingston Middle School went on the class trip. If 252 students went on the trip, how many 8th graders are there? And this in this problem, some of the keywords that we need to kind of focus on, they told us 3/4 of these 8th graders. And then they tell us how many actually went on the trip. So our let statement in this case, we want to know, or let x equal the number of 8th graders. That's what we're trying to find. And so now that we have the let statement, we need to use what we have in the problem in order to set up our equation. So they told us that 3/4 of the students that attended went on this trip. So 3/4 of means to multiply, of the students. So 3/4 of our students. And this number, 3/4 of the students, is equal to the 252 that actually went on the trip. And so now for us to solve, we're trying to get x by itself. Because I'm multiplying by 3/4 here, I can also divide by 3/4. And so when we take care of this, that cancels that out, and it leaves me with x equal to 336. Now we wouldn't leave it here, so we're actually talking about the number of 8th graders. So in this case, I could say that this is 336 students, or 8th graders. Remember, because these are word problems, we want to make sure that we answer it giving exactly what they wanted us to find in the problem. Now, as far as your answers go for number 2 and number 4, I will give those to you. So on number 2, to find the price of one ticket, we get that the cost is $8.75. So again, you can go through and set that problem up using your let statements and the information that they give you in the problem and solve for your x. On number 4, we get that x is equal to 74 degrees. They ask for what was the starting temperature. Let's take a look at the next set of examples. So on number 5, Miss Karen has 7 children in her preschool class. She would like to give each student an equal number of M&Ms. If each child got 23 M&Ms, how many did she start with? So we want to let x equal the number of starting M&Ms, because we're not sure how many she started with, and that's what we're trying to find. Now we know that she has 7 children in her class, and each of them are going to get the same amount. In order for us to equally disperse a number, we have to use division. And so we would take our starting amount of M&Ms, we don't know what that is, but we know that we're going to divide it among 7 students. And when we did this, each student ended up with 23 M&Ms. Now that we have this, we can go ahead and start solving for x. Because we're dividing our x, we want to multiply both sides by that 7 to get rid of it. So when we do this, we get that x is equal to 161. So she started out with 161 M&Ms. On number 7, we have that pocket folders are 39 cents each at the store. If Carolyn paid $7.02, how many did she buy? So, our let statement, let x equal the number of pocket folders. This is what they're asking us to find how many she bought. So now that we have this, we know that each of these pocket folders cost 39 cents. And so that's for each of them. And being that I would be doing multiple cases of addition to get to the $7.02, we would use multiplication here. So if I took the number of pocket folders that I buy and I multiply it by the 39 cents, I should come out with my total in the end. And so now for us to solve, because we're multiplying here, we're going to divide both sides by the 0.39. So in this case, we get that x is equal to 18. So she bought 18 folders. Now to give you guys some answers as far as 6 and 8 go, just so that you can go back and kind of practice those on your own and see if you're getting these right. On number 6, we would get that Braden's score, because that's what they're asking for, Braden's score is a 77. On number 8, they ask, how much does he weigh? And so when we go through and do the problem, we get that x is equal to 177 this case ounces. All right, let's keep going. On number 9, we are driving at an average speed of 52 miles per hour. How long will it take someone to take a 390-mile road trip? So we want to let x equal the length of time, or just time, because they ask how long. How long? So now that we have our let statement, we can use this x to help us figure out how long it's going to take.